And the colors represent the weight of an edge. So you can see that all of these blue edges here are the same weight, the green edges are the same weight, and the orange ones are the same weight. The actual way I define what the weights are doesn't really matter. The important thing is that there are only 4 values for an edge weight in this network. And the question is, can I recover these underlying 4 groups by thresholding? So that means we're going to take this empirical distribution. This is the distribution of edge weights. We're going to move this line back and forth, choose a point, and then anything to the left of the line we call a 0, anything to the right we call a 1. That's what thresholding does. So if we do this and then apply something like the stochastic block model to it, after we thresholded at various points, we find that in no case can we recover the 4 groups. What happens instead is that for each place where we cross one of the edge weights, remember the edge weights are 1, 2, 3, and 4, we do divide the 4 groups into subgroups. But we can never get all 4 groups at once. There's one more box over here in which I've removed all edges, and then I have either 4 groups or 1 group. And that's not very helpful either. So the point here is that it's not that hard to cook up sort of a toy example in which thresholding obscures the underlying structure. So the problem is thresholding discards information. And we want to use that information in the inference. So the idea, the solution here, I think, is to model both whether or not an edge exists, because in real networks they are sparse, meaning that the average degree is some constant, or rather that most of the pairs are not connected. So a dense network is one in which a constant fraction of all pairs are connected. A sparse network is which I only connect to a constant number of people. Most real-world networks are sparse. So in that case, edge existence actually ends up being pretty important. But given that an edge exists, we want to know what the weight is going to be. So we're going to model both of these things simultaneously. We're going to do this using some somewhat fancy tools from machine learning. So we're going to write down a block model.